This is section 9.5, and this is going to be on solving equations that contain radicals. The steps we're going to follow for each one of these is going to be these four. First, we're going to put it in standard form. Now, what's standard form? That's going to be getting the square root by itself. That means we get the square root of whatever stuff's under there, then the equal sign, and then whatever else is over here, whatever other kind of expressions. Could be numbers, excuse me, could be variables, whatever. But the key is that the square root's by itself. Because then we can square both sides. That'll get rid of the radical. Then we'll have something that's a little bit nicer to solve, and we'll have to check our answers. Because when you square both sides of an equation, sometimes you introduce what's called extraneous solutions. Okay, so we start off with the square root of 4x minus 8 plus 2 equals 2. Now that's already crossed off because I went ahead and started doing the work on there. But the first thing is to get it in standard form. So this plus 2 is not part of that radical, so it needs to move to the other side to get it in standard form. So I'll subtract 2 from both sides. So standard form here. That was this step. That gives me the square root of 4x minus 8 equals 0. So I've got it in standard form. Square both sides. So I squared both sides. That squared gets rid of that square root. Those undo each other. 0 squared is just 0. So I get 4x minus 8 equals 0. Now to solve that, that's just a two-step equation. We're just going to have to add 8 and divide by 4. So I'm going to add 8 and then divide by 4, and I get x equals 2. Now the step that you're probably going to forget is the checking. We're going to take this answer of 2 and we're going to plug it back into the original equation for x. So the square root of 4x minus 8 plus 2 equals 2. I'm going to substitute this answer of x equals 2 right here for x. And you can use your calculator to do that. That's going to be 8 minus 8, which is 0. The square root of 0 is 0. 0 plus 2 is in fact equal to 2. So you can just use your calculator and do all that, and you should get 2. If not, then something may have happened with the solving of your equation. It could have been that you made a mistake like in your check or something, but something went wrong somewhere. All right. So if we're going to solve this, we get the square root 4x plus 2 equals negative 3. Now, one thing that I went ahead and noted here was that the square root of some stuff is never going to be negative. So there's not going to be a solution to this. However, if you don't see that initially, right? If you don't see that, because think about it. Remember this symbol is the positive square root. So this is saying the positive square root of some stuff, that's never going to be a negative. So if you see that up front, much like it was with the absolute values. Remember those equations where we had the absolute value equal negative being no solution? Well, same thing with the square root. If you see that, you're done. No solution. But let me just show you what happens if you don't see that. Okay? So let's say that you don't see that. So it's already in standard form, so you start following the steps. You square both sides. You get 4x plus 2 equals 9, because negative 3 squared is 9. We subtract 2, divide by 4, and we get what looks like a perfectly good answer of 7/4. Now, I've labeled it as extraneous because, I'll show you here, when you go to check 7/4 and you plug it back into the original equation here, and you plug 7/4 in for x, this ends up giving you the square root of 9, which is 3. So we get 3 equals negative 3. That's not true. So that's what's called an extraneous solution. That's why you always want to check your answers, because that squaring both sides does sometimes introduce extraneous solutions. And those come in right here. When you squared that negative and you got a positive, it kind of got rid of the problem. That negative was the problem, and when we squared it, it just kind of went away, right? But if you happen to notice that the square root of some stuff can't be a negative number, so you could just jump straight to no solution. Let's look at another example here. It is already in standard form. This one, well, I mean, what's better than an equation with one radical? Psh, an equation with two radicals, of course. I mean, look how much fun that looks like here. It's already in standard form because I've got the square root by itself. So I'm going to square both sides. Check it out. I square both sides. Both radicals go away. And I end up with x plus 2 equals 2x minus 5. So in chapter 2 is where we solve equations like this. So you got to get the variables on one side, constants on the other. So I'll subtract 2x from both sides, and then I'll subtract 2 from both sides. I get negative 1x equals negative 7, so I'll divide by negative 1. I get x equals 7. Now before I commit to that and say, yep, that's my answer, don't forget to check it. So we need to plug it back into the original equation for both of these x's and make sure that those are equal. So, is the square root of 7 plus 2 equal to the square root of 2 times 7 minus 5? Well, yeah, I get the square root of 9 is the square root of 9. 3 equals 3. So that's another type of radical equation that we get. This is another type of radical equation. Now you can see there's a squared under there. That's going to pose a new problem for us. It is in standard form. The square root's by itself. So I'm going to go ahead and square both sides. In doing so, that square root and that squared will undo each other. So now I'm left to solve x squared plus 13 equals 49. This is not the equations from chapter 2. These are the quadratic equations from chapter 6. All right? Now, to solve quadratic equations, you have to be able to either use the square root property or factor it. So, to solve any equation with a squared, you have to get it into this form and then factor it. Now you can also use the square root property, which we learn in chapter 10. If you already happen to know that one, then that's awesome. You can go ahead and skip to it. But for now, we assume that you only know the stuff from these prerequisite sections, which is all about factoring. So I'm going to get everything on one side and get it equal to 0. So I get x squared minus 36 when I subtract 49 from both sides. That's going to factor as the difference of two squares, okay? Because that's x squared minus 6 squared. If this doesn't sound familiar, you should go back into Hawks and review section 6.6. All right. You can also, if you're struggling with this, you can also ask me, or you can check my website and see if I happen to be teaching Math 90. And if I am, you can go look in Math 90 and see if that section of lecture notes is there for you. If not, just send me an email and I'll gladly email those to you so you can see those lecture notes, just in case Hawks isn't all that helpful for those. So if we factor this as the difference of two squares, that's going to factor into x minus 6 times x plus 6. Because this product, these two things are multiplying to be 0, one or the other of them has to be 0. So we split those apart into two separate equations, both equal to 0, and solve them individually. So we get x equals 6 and we get x equals negative 6. I do need to check both of those answers to make sure that they both work out. So the next page is me taking the original equation. I'm going to check x equals 6. So I substituted 6 into here, and I got square root of 49 is 7. Okay, good. Negative 6, okay, plugging negative 6 into the equation. Negative 6 quantity squared is also positive 36, plus 13 is 49. Okay, that one checks out too. Both solutions check out. So don't assume that if you get two solutions that one of them is going to be extraneous. Not necessarily. Alright, this one's got a cube root to it. Woo! Now a cube root can be negative. A square root can't. An absolute value can't. But a cube root can. So don't just immediately look at that negative and say no solution. I wish. Those are the easy ones. But instead, we're going to get it in standard form. Alright, that root's by itself. Now, here's the difference. Because this equation has a cube root to it, we have to cube both sides. Remember before my steps I was squaring both sides. Well, that's because I had a square root, right? That's how you undo a square root with a squared. Now I have to undo a cube root, so I have to cube both sides. So I cube both sides, that gets rid of the cube root. So I end up with 7x plus 1, negative 5 cubed becomes negative 125. Step 3 is to solve that equation. All right, I'm just going to subtract 1 and then divide by 7. So I get negative 18. That wasn't too terrible. Now, here's the thing. Cube roots don't have extraneous solutions like square roots do. So you don't have to check the cube root equations. If you just get in the habit of doing it, that's great, but you certainly don't have to. Oh, doggo's awake. Oh, nope, she's just up spinning. She's not awake. And she's back asleep. So you don't have to. If you do check it, that's okay, but you don't have to worry about the extraneous solutions. Okay. So it may look like I'm going backwards from the cube root back to a square root, but you'll see what makes this one, pretty ugly. So first thing we got to get in standard form. We got to get that 3 moved over to get that square root by itself. So I'm going to move that 3 over. So I get the square root, 3x plus 13 equals 2x minus 3. I am going to square both sides. In doing so, that squared will get rid of that square root. So that just left-hand side becomes 3x plus 13. Squaring this right-hand side is the same as multiplying that by itself. Do not square 2x and then 3 and tell me that that's going to be 4x squared minus 9. It's not. Or 4x squared plus 9. Either way, it's not. So we do have to distribute all that out. So once I multiply all those things out, I get this. I can combine those like terms. I get 3x plus 13 on the left side. On the right-hand side, I get 4x squared minus 12x plus 9. All right, this is a quadratic. It has a squared. Remember in the last, 2 examples ago, if you're solving an equation with a squared, you have to move all the terms to one side and get it equal to 0 and then factor it. So moving those terms to the other side gives me this equation. We now have to factor this. And whoo doggy. This one in chapter 6, this factors using the AC method. Now, if you factor differently, if you factor using a different method than the AC method, if you just kind of use like some kind of a trial and error or something, however you factor it, that's okay. But just know that to get from here to here, I'm skipping a bunch of stuff that is prerequisite stuff. All right, this is the chapter 6 sections. So it might be in your best interest to go ahead and maybe redo some of those and refresh your memory on how to factor. So once you get this factored, so remember factoring is the opposite of FOIL, right? So FOIL, or the distributive property, factoring is the opposite of that. It takes this expression here and it rewrites it in terms of these two parentheses. Whereas the distributive property, or what some people call FOIL, is multiplying all that out and combining those like terms. So once you get it factored, you're going to set each one of those factors equal to 0 and solve those separately. So we get 4x plus 1 equals 0 and x minus 4 equals 0. And I solve those on the next page. So solving both of those, I get negative 1/4 and 4. Now, spoiler alert, that one's going to be extraneous. So let's see why. If I go to check it, I start off by checking negative 1/4. Here's my original equation here. Plugging negative 1/4 in for both of those x's. Using the calculator on this left-hand side, that whole left-hand side simplifies to be 1/2. This ends up being negative 1/2. So that's not true. That's an extraneous solution that showed up by squaring both sides. Those sometimes creep in there. 4 turns out to be okay. If I plug 4 into the original equation for both x's and use the calculator on this expression here, I get 5 plus 3 is 8. That's true. So that means x equals 4 is my only solution. Now it is possible that both of your answers can be extraneous. It's possible that neither answer is extraneous. So just kind of know that going in, that if you get one that's extraneous, don't just assume that the other one is okay. It most likely is going to be okay, but just don't make that assumption. So, okay, that completes section 9.5.